Hey guys, Marco here from Aviator Live CS. Welcome back to the channel. Today, as promised, we'll continue reviewing the 737 NG systems, and we will be talking for the next series of videos about engines and APU. What we are going to review today is system overview, system limitations, and over and under displays. We'll be talking about primary and secondary engine indications. We have a lot of things to talk about there, so please bear with me. Let's talk about the overview. And we have an CFM 56-7B26 or 27 engine on the 737-800 NG. It's twin spool axial flow turbofan. We have a low N1 and high pressure N2 compressor and turbine. N1 and N2 are not mechanically linked. The fan consists of 24 titanium blades. Fan and booster N1 is a 4-stage compressor. The high pressure compressor N2 is a 9-stage compressor. The engine gearbox is powered by N2 shaft. Engine bleed air is taken from the 5th stage of the N2 compressor. During low power settings, air from the 9th stage of the N2 compressor is used to help meet demands. Let's review the system limitations, and we have on the AFM maximum and minimum limits are red, caution limits are amber. This is for the engine limit display markings. So here we don't really need to know the exact numbers for the limits. It's basically indicated by the markings. Engine ignition, which we have it here, must be on for takeoff, landing, operation in heavy rain, anti-ice operation. Thrust operation with assumed temperature, reduced takeoff thrust is not permitted with anti-escape inoperative. Reverse thrust, intentional selection of reverse thrust in flight is prohibited. Airplanes operating under FAA rules in flight, APU bleed plus the electrical load, maximum altitude is 10,000 feet, if we have to use both. APU bleed only, maximum altitude is 17,000 feet. APU electrical load, maximum altitude is 41,000 feet. Okay, let's talk about some non-AFM operational information. The APU bleed valve must be closed when the ground air is connected and isolation valve open, engine number 1 bleed valve open, isolation, and engine number 2 bleed valves open. APU bleed valve may be open during engine start, but avoid engine power above idle. After 3 consecutive aborted start attempts, a 15-minute cooling period is required. Run the APU for 2 full minutes before using it as a bleed air source. So those are the system limitations, basically. And now we'll start with the long part here, which is the over and under displays. Engine indications. Primary and secondary engine indications are provided. Engine indications are displayed on the center forward panel upper display unit, lower DU, or the captains or first officers inboard DU. N1 and EGT are the primary engine indications, as you can see here. The primary engine indications are normally displayed on the center forward panel upper DU. If that unit fails, the display automatically moves to the lower DU. The primary engine indications can also be manually selected to either the captain's or first officer's inboard DU or the lower DU using the respective display select panel here. Okay, now let's check what we have at the top of the upper display unit, and I want to show you this, where I want to talk about this information here. And we'll start with the total air temperature indication. It's displayed, the label is cyan, the temperature is white, and it's displayed in the degrees Celsius. Now, if we want to talk about these temperatures a little bit, just to understand what's the total air temperature, if some of you don't know, I found this easy definition here for some of the temperatures. I believe it's good to know. So the outside temperature is the outside temperature. That's enough said what exactly what it says there. The static air temperature is the temperature of undisturbed air. In other words, it's the temperature of the air around the aircraft. It's not affected by the movement of the aircraft through the air. Think of it as pretty much the same thing as the OAT. RAT is the RAM air temperature, interchangeable with TAT. TAT is the total air temperature, and that's the indication we have here. This is the static air temperature plus the temperature rise associated with highest speed flight. So what exactly is the temperature rise, and do we need to know what it is? The RAM rise is the result of heating due to air friction and compression. Think of it as the temperature that the aircraft's skin feels. RAM rise only becomes a factor at speeds above approximately 200 knots, and it is proportional to the aircraft speed. So the faster you're flying, the higher the RAM rise. Okay, let's talk about the thrust mode display. Here it is green, and this is the active N1 limit reference mode. With N1 set auto and off on engine display control panel in auto, active N1 limit is displayed by reference N1 box. With N1 set auto and off on engine display control panel in either 1 or 2 or both, other than auto, the thrust mode display annotation is man. So the N1 set, it looks like this. Remember, it's in the center forward panel, and we're going to talk about it in the next slide. Active N1 limit is normally calculated by the FMC. Thrust mode display annotations are, so what we can see here, actually, we can see all these modes. Takeoff 1, which is the rated takeoff 1. Takeoff 2, assume temperature reduced thrust takeoff is DTO, DTO1, DTO2, climb 1, climb 2, cruise, go around, continuous, and if we see a dash line, FMC, not computing thrust limit. Number 3 is the selected temperature, is displayed green, and it is the selected assumed temperature in degrees Celsius for reduced thrust takeoff N1. Repeats data selected on takeoff reference page in the FMC. Number 4, we have the auto throttle limit indication, illuminated white. The FMC is not providing the auto throttle system with N1 limit values. The auto throttle is using a degraded N1 thrust limit from the related EEC. Replaces thrust mode display annotation when illuminated. Now here you see the N1 set again, and we're going to talk a little bit more about it. N1 set auto and off, you can see here. In auto, both reference N1 box set by FMC based on N1 limit page and takeoff reference page in the FMC. Displays reference N1 box at active N1 limit for auto throttle. If we select both reference N1 box and readouts manually set by returning N1 set in and off, this one here, has no effect on auto throttle operation. If we select 1 or 2, respective N1 reference box and readout manually set by turning N1 set in and off, again, has no effect on auto throttle operation. Number 2 here is the N1 set in and off, spring loaded to center. If we rotate it, positions reference N1 box and readouts when N1 set auto and off is set to both 1 or 2 positions. Now let's talk about the reference N1 box here. Displayed green with N1 set auto and off in auto, 1, 2, or both position. Position corresponds to digital value on the reference N1 readout. Number 4, N1 red lines, you can see them here. Displayed red, N1% RPM operating limit. Number 5 is the N1 command sectors, displayed white. Momentary difference between actual N1 and value commanded by thrust lever position. Number 6 is the N1 RPM readouts. They are digital, displayed white, normal operating range. When they are displayed red, it means that the operating limit has been exceeded. On ground after engine shutdown, red box indicates an in-flight exceedance has occurred. Number 7 is the reference N1 readouts, displayed green. Manually set N1% RPM when N1 set auto nav is in both 1 or 2 position. We will see a dashed line when N1 set auto nav is in auto position and FMC source invalid. When N1 set auto nav is in auto position, may indicate fixed derate, assumed temperature derate, or a combination of fixed and assumed temperature derate. It's not displayed when reverse thrust is selected. Number 8 is the N1 RPM indications, displays N1% RPM, displayed white is the normal operating range, and when we see it red, it's the operating limit exceeded. And number 9 here is the N1 maximum buck, displayed amber, N1 value for full rated thrust, computed by the EEC through all phases of flight, upper limit of auto throttle operation. Again, this one is not displayed when the reverse thrust is selected. Now let's review the thrust reversal indications and the thermal anti-ice indication. Thrust reversal indications, we can see either amber or green. Amber, thrust reverser is moved from stowed position, and when they are green, thrust reverser is deployed. For the thermal anti-ice indication, it's displayed green. It means that the cowl anti-ice valve is open, and displayed amber is the cowl anti-ice valve is not in position, indicated by related engine anti-ice switch. Now let's review the engine fail alert. Engine fail alert, displayed amber, engine operating below sustainable idle, which is less than 50% N2, and the engine start lever in idle position. Alert remains until engine recovers or start lever moved to cut off or engine fire switch pulled. Now we have some crew alerts, and we're going to talk about each of them. You can see it here, still in the upper display unit, remember? Start valve open when it is illuminated amber. We can see it steady. It means that the respective engine start valve open and air is supplied to the starter. When we see it blinking, on command opening of a start valve, alert is displayed and solid amber boxes are displayed on annunciated positions for that engine. All 3 boxes blink for 10 seconds. Then alert remains on steady and solid amber boxes are removed. So let's read what the note says here. Blinking is inhibited during takeoff from 80 knots to 400 feet RA or 30 seconds after reaching 80 knots, whichever occurs first. During landing below 200 feet RA until 30 seconds after touchdown. During periods when blinking is inhibited, alerts illuminate steady. Okay, this blinking condition repeats for the 3 alerts, basically. So the first one we just read, uncommanded opening of the start valve. And then the next one will be for a condition of low oil pressure. And the third one will be for an impending bypass. All right, the low oil pressure alert, when it's steady in amber, oil pressure at or below red line. Oil filter bypass alert, it's this one here. A steady amber indicates an impending bypass of a scavenged oil filter. Now let's talk about the secondary engine indications. Secondary engine indications are N2, fuel flow, oil pressure, oil temperature, oil quantity, and engine vibration. The secondary engine indications, except for fuel flow, are manually selected to either the captains or first officers inboard DU or the lower DU. using the respective display select panel and the engine switch on the engine display control panel. Fuel flow is displayed full-time on the upper display unit below the primary engine indications. The secondary engine indications are automatically displayed when the displays initially receive electrical power, in flight when an engine start lever is moved to cut off, in flight when an engine N2 RPM is below idle, a secondary engine parameter is exceeded. When the secondary engine indications are automatically displayed, they cannot be cleared until the condition is no longer present. So what we just read here is what we have here, basically. The only thing I just want to clarify here, when they mention CDS, the CDS is the Common Display System, which supplies information to the flight crew on 6 flat panel liquid crystal display units. So that's a CDS. If we have the N2 indications here, number one is the N2 red lines displayed red, N2% RPM operating limit. Number two is the N2 RPM indications right there. Displayed white, normal operating range. Displayed red is the operating limit exceeded. Number three, N2 readouts digital. Displayed white, normal operating range. Displayed red, operating limit exceeded. On ground, after engine shutdown, red box indicates an in-flight experience has occurred. When we see the cross-bleed start indication here, it means that cross-bleed air is recommended for in-flight start. It's displayed when airspeed is less than required for a windmilling start. We have the fuel flow switch spring-loaded to rate to this position. In this position displays the fuel flow to the engine. If we move it to used, displays fuel used since last reset. After 10 seconds, display automatically reverse to fuel flow. If we move it to reset, it resets the fuel used to 0, displays fuel used for 1 second, decreases to 0, then displays fuel flow. Number two is the fuel flow readout digital, and we can see it here. Displayed white, fuel flow to engine with fuel flow switch in rate position, kilograms per hour times 1,000. Number three is the fuel use readout, which is digital as well, displayed white when fuel flow switch moved to used or reset. So now we'll talk about the oil pressure and oil temperature indications. Before we continue, I just want you to notice that the readouts for both of them and the pointer for both of them, they have the same information, basically white, normal operating range, amber, caution range, and red is the operating limit reached. So we know that number 1 and 2 for each is exactly the same, but the display for the oil pressure is indicated in PSI right here. Number 2 displays engine oil pressure, the pointer. Number 3 is the low oil pressure amber band. It's displayed amber, low oil pressure caution range beginning at red line. Variable depending on N2% RPM above 65%. Amber band not displayed below 65% N2. Number 4 is the low oil pressure red line, displayed red, the oil pressure operating limit. For the oil temperature indications, this is the display in number 1 is in degrees Celsius, and exactly the same for the temperature here for the pointer is in degrees Celsius. Number 3, we have the high oil temperature amber band, displayed amber, oil temperature caution range, and we have the number 4 here is the high oil temperature red line, displayed red, oil temperature operating limit. We also have the oil quantity indications here in the lower display unit. Displays usable oil quantity in percent full. Video is reversed and low white displayed for low oil quantity. We have a couple of notes here. Indicated oil quantity may decrease significantly during engine start, takeoff, and climb out. If this occurs, engine operation is not impacted and the correct oil quantity should be indicated during level flight. An oil quantity indication as low as 0 is normal if windmilling N2 RPM is below approximately 8%. Engine vibration indications, number 1, readout displayed white, engine vibration level, video is reversed for high vibration. Number 2, high limit, displays tick mark and thick line. Number 3, vibration pointer, we can see it here, display white, engine vibration level. And to complete the over and under displays, we will be talking about the compact engine displays. The following changes occur to the secondary engine display in the compact engine displays. N2 RPM indications, as you can see them here. N2 changes from a round dial display to a digital display. The digital display is framed by a red box after engine shutdown on the ground if an in-flight exceedance occurred. You see the oil pressure and the oil temperature displayed as digital readouts only. The digital readouts display amber or red if limits are exceeded. The vibration indications are displayed as a digital readout only. Crossbreed start indications are displayed on the side of N2 here. Hey guys, this is the end of the video for today. By the way, I want to recommend you a website called sim4pilots.com. I'm going to leave a link in the description below. I hope you find this website interesting. It is about the Boeing 737 procedures. So guys, if you like the video, give me a thumbs up. If you're not subscribed to the channel yet, please do it now. And if you believe these videos could be useful for somebody else, please share them. And that's going to help me a lot to grow the channel. Next week, we will continue reviewing the engines and APU. Until then, guys, please take care and hope to see you soon.